Okay, this is another example out of the book in chapter 4. It's question 9 on page 152. It's about capacity requirements for a bicycle manufacturer, the Tough Rider Incorporated. And at the end of it, basically, they need to know how many workstations they're going to need for the coming year to meet with the demand forecast. All right, so right here I've just included the table from the question and the formula and some of the definitions. So we can see D is our demand, P, lowercase p, is our processing time. We have N, the number of hours per year that the process will operate, the capacity cushion, the input units required, and that's right out of the book. That's essentially the number of workstations. That's the answer we're looking for. And then the units that are made in each lot, and of course that's shown up above, the lot size, and the setup time per lot, which is again shown above, a bit of difference. So to start out, I guess what we'll do is we'll work out the bottom, essentially the amount of time, hours that each unit operates per year, and build in the capacity cushion. So to get that, essentially we're just going to take from the question, the number of hours in a day, 8 hours in a day that the workstations work. We're going to multiply that by the number of days they work in a week and the number of weeks per year. And that is going to be equal to 2,000 hours per year of operation. And then we're told that the capacity cushion is 15%. So the denominator down here essentially is all it's doing is taking 85% of our 2,000. So just to work that out, I'll do it the way that the book does. It's 2,000 times 1 minus 15 over 100. And so that's going to be equal to 1,700. So that is 1,700 hours per year available to us per workstation with a 15% capacity cushion built in. Okay, so to figure out the numerator, we're going to sum together all of the processing and setup hours required for a year's demand for each different product or process that we have here. So essentially, just to work this out, we're going to have for touring bikes, I'll do each one separately. Our D is going to be equal to 5,000. Okay. Our P is our processing time, hours per unit. And then we're going to have our Q, which is our units per lot, and that's 100 units per lot. And what's the last thing we need is the setup time per lot is going to be equal to 2 hours in this case. So for touring, what we're left with is 5,000 times 0.25 plus 5,000 over 100 times 2. So essentially these numbers are the number of hours it takes to make each unit. So this is the total for 5,000, so it's going to be 1,250. And we have over here, we have essentially what this is the number of lots. 5,000 over 100 is the number of lots we're going to do times the number of hours it takes to set up for each lot. So in this case it's going to be 100. So what we have is 1,350. Now for the mountain, we have a demand of 10,000. Each one takes a half an hour to produce. And we have 10,000 over, and in this case our lot size is again 100. And in this case it's going to take 3 hours to run. So that will give us 5,000 plus 300, which is 5,300. So that's for our mountain, that's for our touring. So now to find out the number of units that we need, we take all of the things that we have thus far calculated. So essentially we're going to take our 1,700 hours per year, our 1,350 hours per year for touring, and our 5,300 hours per year, and we're going to get the number of machines that we need. So that's M equals, so 1,350 plus 5,300 over 1,700, and that gives us 3.91 machines, or workstations in this case, for assembly. Now we obviously can't have 0.91 of a workstation, so we will always round this up. So if this had been 3.01, we would still need 4 workstations in order to meet the demand with the capacity cushion requirement.